All right, today we get to learn the last method that we're going to talk about for solving quadratic equations. So far we talked about graphing, which once again, graphing, it'll work for all of them, but really you only want to do it if you have technology handy to do it for you, so that it's exact. Then we can solve by finding square roots, but that only works if our b value is 0, because we can't do that if we have that bx term there in the middle. We can solve by factoring, but sometimes we get quadratic equations that are not factorable on the side of when it's equal to 0 once we get it into standard form. So then a method that will work for any quadratic formula, any quadratic equation is called the quadratic formula. So the quadratic formula, once again, first you need to write your quadratic equation in standard form. You have to make it equal to 0. If it's not equal to 0, then you don't see what your a, b, and c values really are. So it says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So here what they've done is they've pulled out my a value, b value, c value. So a is 2, b is 3, c is -5. Then they took x equals opposite of b, so -3, plus or minus the square root of 3 squared, minus 4 times a times c, all over 2a. So first thing you do is plug it in, and then you simplify it step by step. So if I were to simplify this one, I'd have -3, plus or minus the square root of 3 squared, which is 9, minus 4 times 2 is 8, 8 times -5 is 40, so I'd have 9 minus -40, all over 2 times 2, which is 4. So -3 plus or minus 9 minus -40 is like plus positive, so square root of 49 over 4. So I have -3 plus or minus square root of 49 is 7 over 4. Now, remember our plus or minus. What this means is I actually have two solutions there. So I need to split that apart into both. So I have x equals -3 plus 7 over 4, or x could equal -3 minus 7 over 4. So this is taking care of both x-intercepts of my graph. So if I do this, -3 plus 7 is 4 over 4, so x equals 1. Or -3 minus 7, so that'd be plus a negative, so it'd be -10 over 4, which would simplify down to -5/2. So notice we still get two answers there, even though right here it just looks at like 1. So we're going to do a couple of these examples here to help us out. So step 1, pull out your a value, b value, and c value. Identify those so that it's easier to put it into the quadratic formula. So my a value here is 1, b value is -3, and c value is -10. This should be equal to 0 here. Okay, so x equals, here, I'll write it up here. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So x equals opposite of b. That means I'm going to have the opposite of -3 plus or minus the square root of b squared. So make sure you put that -3 in parentheses. Minus 4, you'll always have that 4 there, times a times c, all over 2a. Notice I wrote things in there, even if I could have simplified them right away. So I know that 2 times 1 is 2, but I'm going to write that in there so I get in the habit of always putting my values in. So opposite of -3 is 3, plus or minus the square root of -3 squared is 9, minus 4 times 1 is 4, times -10 is -40, all over 2. So you get 3 plus or minus square root of 49 all over 2. So x equals 3 plus or minus 7 over 2. Now we need to split that apart. So x equals 3 plus 7 over 2. X equals 3 minus 7 over 2. 3 plus 7 is 10. Divided by 2, so x equals 5. Or 3 minus 7 is negative 4 over 2. Negative 4 divided by 2 is negative 2. So x equals 5 or x equals negative 2. We're going to practice another one of these. I would like you to try this on your own first. Pause the video and see if you can get the correct answer before you come, and then come back and watch me walk through it. So 5x squared plus 16x minus 64 equals 0. So pause it, then press play and come back. All right, so step 1, A is 5, B is 16, C is negative 64. So x equals opposite of B plus or minus the square root b squared minus 4 times A times C all over 2A. Okay, so negative 16 plus or minus the square root. 16 squared is 256 minus 4 times 5, which is 20, times negative 64, I believe is 1,280. Yep. So minus negative 1,280. Then 2 times 5 is 10. So at this point, it's just a matter of following order of operations. Once you put it in there, you just need to know how to simplify this side of the equation. So 256 plus, since it's minus a negative, 1,280 is 1,536 divided by 10. So now I need to find the square root. 1,536. Ooh, which is not a pretty number. Wait a second, I think I did something wrong. 16 squared is 256. Second square root. Yeah, 39.19. So what I would do, oh, that's why. I have the wrong problem here. Sorry, guys. Should be negative 84 instead of negative 64. So it helps if I give you the correct values here. So instead of 1,280, we should have 4 times 5 times negative 84, which gives me 1,680. Then this number under here, let's see, we're going to erase some things. Need a little bigger eraser. So 1,680 plus 256, 1,936. Square root of that is 44. This looks a lot better for this problem. Over 10. Okay, so now, remember this is where I had to split it into two problems. So I have x equals negative 16 plus 44 over 10. or x equals negative 16 minus 44 over 10. So negative 16 plus 44 is 28. 28 divided by 10 is 2.8. Or negative 16 minus 44 is negative 60 divided by 10, and x equals negative 6. So writing down the correct problem is helpful. Sorry about that. But yeah, I wouldn't have wanted, you could have factored this, maybe, and then gone from there, but sometimes we don't get nice numbers. Like here, you wouldn't have been able to factor it because it would have been a decimal, so you would have really struggled with that there because it wouldn't have been whole numbers. And sometimes we don't get exact values here because numbers underneath are not always perfect squares. So we can apply this to the shape of a projectile. So when you throw a baseball, think about the shape of the baseball. When it leaves your hand, no matter how much of a line drive it is, it's always going to rise a little bit and then fall. So the arc of the ball can be modeled by the equation y equals negative 0.05x squared plus 0.75x plus 4, where x is the horizontal distance from Jacob and y is the height in meters of the ball. So it says how far from Jacob does the ball land. So I'm going to pull out my a value, which is negative 0.05. My b value is 0.75. And my c value is 4. So x equals opposite of b, so negative 0.75, plus or minus the square root, b squared minus 4 times a times c all over 2a. All right, so now we're going to start the simplifying process. So negative 0.75 plus or minus the square root of 0.75 squared, which is 0.5625, minus 4 times negative 0.05 times 4 is minus negative 0.8 all over 2 times negative 0.05, which would be negative 0.1. So this becomes plus, so negative 0.75 plus or minus the square root 0.5625 plus 8/10, which is 1.3625 all over negative 0.1. So now the square root of that is a gross number. So what we're going to do is we're going to round this. We'll write it as 2 equations here before we round. So since we didn't get an exact answer, we're going to write it as negative 0.075 plus the square root of 1.3625 over negative 0.1, or negative 0.75 minus the square root of 1.3625 all over negative 0.1. So at this point, it's really important how you put this into your calculator. So you can either put the top part in parentheses, like all of this in parentheses, and then divide by negative 0.1, or you can just do the top part, hit enter, and then divide by negative 0.1. So either way you do it, it's fine. Just make sure you find the answer of the top part first before you divide. So I have negative 0.75 plus the square root 1.3625. I'm going to hit enter, and I got 0.417261753. Then we're going to divide by negative 1/10, which is negative 4.17 approximately. So we're going to round to the nearest hundredth here. Well, if I do this one, do the same thing, except now I'm going to do negative 0.75 minus the square root of 1.3625, enter. I'm done, divide that by negative 1/10, and I get 19.17. So if this were not a story problem, and this is also in meters, if this were not a story problem, we would just be content with these two answers. However, this is a story problem. So if you think about a person throwing a ball, here's Jacob. He threw a baseball, and it's going through the air. So we want to find the horizontal distance in front of him where it lands. What we found here is if we were to continue this behind him, what it's saying is that parabola would start negative or 4.17 feet behind Jacob. I don't want to know where it would go behind him. I want to know where it would go in front of him. So the only answer I need for a story problem like this is the positive value, because I don't want to know the backwards value. Once again, if it were not a story problem, I would need to know both values. If you have problems like this where it is not a perfect square, just round your answer to the nearest hundredth. If you have questions, please come back on. Notice I did not do this all in one step. It is very important. I would say simplify it one step at a time. Yes, you're using your calculator, but also if you do it one step at a time, then it's helping you to not just make calculator errors. Also, I do have a song. I wasn't actually going to sing it for you, but if you're having a hard time memorizing this quadratic formula, you can sing it to the tune of Pop Goes the Weasel. So you can say x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Sorry, that was horribly out of tune. If we were in class, I would make you sing it with me over and over and over and over again until it gets stuck in your head. But this is something you need to memorize because once again, this works for every single quadratic equation. If you just don't feel like doing any of your other methods, but you know the quadratic formula, this will work every single time. Downfall of this is there's a lot of steps to it, and sometimes it's kind of tedious to go through those steps all the time. Sometimes it's a lot quicker to do square roots or factoring and then using the zero product property. But if you know the quadratic formula, then you can do it for every single value or every single quadratic equation. So please take your time with this. Please make sure that you are doing the work, doing it step by step. Take your time. Don't give up. And if you have questions, please let me know.